Hello, this is Dr. Mears. Today we're going to be solving systems through doing it of word problems. I'm going to redo the word problems. I'm going to talk a little bit about what it's actually telling you, and then we're going to start. So here we go. Wendy is starting a catering business and is attempting to figure out who she will be using to transport the food to different locations. She has found 2 trucking companies that are willing to make sure her food arrives intact. Peter's Pickup charges 40 cents per mile and charges a flat fee of $68. Helen's Haulers charges 65 cents per mile and charges a flat fee of $23. First, I want to explain what a catering business is. A catering business is a business where they prepare food, a large quantity of food, let's say for a birthday party or for a wedding, or even for businesses when they do luncheons, and they will prepare it at their place, and then they'll have to put it on a truck and bring it to wherever they're going to be delivering to. So that's what a catering business does. So Wendy is looking at 2 different companies to pick up the food and bring it to where she needs it to be brought. Peter's Pickup is one and Helen's Haulers are the other. So this is a system because you've got it. We're going to be making 2 equations. So let's go. First is to define your variables. So we have to know what we're talking about. We have to know what the x variable is, so what we're going to be inputting, and then what the y variable is, what we're going to be getting out. So let's look for some keywords such as per, each, for, one, and I see right here 40 cents per mile. And per mile makes sense because we're going to be traveling. They need to take the food from one location to the other. So our x variable is going to be the number of miles that we travel. Number of miles. Now the y variable, we are going to be talking about what each company charges. So we input the number of miles and what we're going to get out is the total cost. And that's going to be in dollars. Okay, next. We need to write a system of equations to model the above situation. Now, system of equations, the system that we've been doing the slope-intercept form of equations. That's what we were doing. I have not taught you the other one yet, but I am going to be doing that shortly. However, we're going to be writing in slope-intercept form, which is y equals mx plus b. So now you have to remember to find your m and your b, and you may have to do some algebra to actually get to that b and get to the m. So let's see what information they give us. We're going to do Peter's Pickup first. That's the first one here. So we're going to go up here. Let's find Peter's sentence. So here's Peter's sentence. Peter's Pickup charges 40 cents per mile and charges a flat fee of $68. Now, when I see flat fee, I think that's the fee that I charge no matter what. So if he traveled no miles, 0 miles, I'm still going to end up paying $68. So this is, in fact, our y-intercept. So I'm going to put b on top of that. Now I have another number here, and that's 0.4, and it's 0.40 per mile. Now when you see this per, or if it was each mile, or if it even was for 1 mile, this is denoting slope. So this is my m, this is my slope. So this is really nice because that's what I actually need. I need my m and my b. So there's going to be no extra algebra to go along skill-wise. All we really are going to have to do is take our m and substitute 0.4 in for our m. So we're going to get y equals 0.40 x. Our b is a positive 68, so plus 68. That's it. We got our equation. So this is the first way that we were actually writing equations when we started writing equations. Next is Helen's Haulers, and you'll see that one's down here, Helen's Haulers. So let's go to Helen's sentence, which is right here. Helen's Haulers charges 65 cents per mile and a flat fee of 23. So again, this is going to be our slope, and this is going to be our y-intercept, which is our b. So we got both numbers here. So again, all it is substituting our 0.65 for m and our positive 23 for b. So there's our 2 equations. We now have a system. Part C, for what distance would the cost of transporting the produce be equal for both companies? Use substitution to find your answer. So this is going back to our skill of solving for x and y using substitution. And you just took a formative on that. So what we do is both of these equations are solved for y. So we would take out this y and input what the other equation says that it is equal to. So 0.65x plus 23 equals, and then this side, 0.40x plus 68. Now our skill of solving for x starts. I'm first going to move over the x term, and by subtracting, this was originally a positive, so remember I need these to do the inverse here. So I'm going to minus 0.40x to both sides. 0.65 minus 0.40 is 0.25x. Bring down my positive 23. Bring down my equal sign and bring down my 68. Now I'm going to subtract 23 from both sides. Because again, inverse, bring down my 0.25x, bring down my equal sign. 68 minus 23 is going to give us 45. I'm not done yet. This 0.25 is linked by multiplication, so I do have to divide it by both sides. I now have x by itself. X equals, and 0.45 divided by 125, I think that's going to give us 180. And let's see, x equals 180. So let's go back to see what the x variable represented. And the x variable represented the number of miles. So down here, this is the number of miles. And let's look back at the question to see what the number of miles, what context we have. So it says, for what distance would the cost of transporting the produce be equal? So the distance where the cost would be equal is 180 miles. So I wonder what that actual cost is. And you got it. We're going to most likely be finding our y, which is that next step. So let's see what the next question asks. I bet you it asked for the cost. Part D. What is the equal cost? There you go. Use the x you just found and substitute it into the equation to find y. And it says an equation, so we can pick either one. So remember, our x was 180 miles. I'm going to go back and choose that first equation, y equals 0.40x plus 23. Is that it? Let's make sure. No, 0.40x plus 68. I'm sorry. Plus 68. Going too fast. Okay. So this was my first equation, which was Peter's pickup. What they're asking me to do is use the x, which is 180, and substitute it into an equation to find y. So we are going to be substituting in 180. So it's going to be 0.40 times 180 plus 68. So y equals, taking out my trusty old calculator, 0.4 times 180 gives us 72. And now we're just simply going to add 68, and I'm going to get 140. So y equals 140. And now this is in dollars. There's no decimal, so it would be 0.00, but there's no change. So you can write it either way. So what is the equal cost? Let's write complete sentence with context. The equal cost will be $140. There we go. So we actually just solved for x and y like we've been doing. All right, let's see what's next. The system of equations has been graphed using Desmos. So Desmos is a graphing, online graphing, and we've used it a few times before. But why it's nice is because I can actually graph it and attach it to these worksheets. So it's graphed for us, which is awesome. Let's see what they want us to do with it. Part E, label the x-axis number of miles. So we're simply just going to label the x-axis. And I like to put a little x right here because this is the x-axis, but I also labeled it what they wanted me to. Label the y-axis total cost. So here's the y-axis, so let's label it total cost. Awesome. So now we have some labels. That's some good points right there. Okay. Part G. Identify which line is Peter's pickup by labeling it. Explain how you knew it was Peter's line. Before I identify his line, I'm going to write down his equation. Y equals 0.40x plus 68. The reason why I'm going to write down his equation is because this is our B, which is our y-intercept. And our y-intercept is where we would start on the graph. So explain how you knew it was Peter's line. Basically, I'm going to look for 68 on the y-axis and follow the line. So I'm actually going to tell you how I did it, and that's going to be explaining how we found it. So look for 68 on the y-axis and follow the line. So let's go. This is the y-axis here. Let's look at the numbers. This is 0. This is 50. So I'm wondering what they're counting by. Let's look at the little lines. I'm thinking they're probably counting by tens. So 0, 10, 20, 30, 40, 50. So each box is worth 10. 60, and then this is 70 up here. And if you notice on your worksheet, because you might not see it clearly on mine, this would be 68. So this line, following it here, this line is Peter's. So there we go. Because it crosses the y-axis at 68, that's our y-intercept. Okay, let's see what's next. Identify which line is Helen's by labeling it. Explain how you knew. So let's write down Helen's, which is y equals 0.65x plus 23. Now I'm just going to make sure, again, I got that slope and y-intercept, 0.65, 23, yep. All right, and again, this is going to be our B. So this is going to be our y-intercept. So I'm going to look for 23 on the y-axis and follow the line. Now I know it's the other one on the graph. It is the other line because we do only have two, but let's just make sure that it's correct. So let's go and make sure that it crosses the y-axis at 23. So remember, we're counting by tens here. So 0, 10, this is 20, this is 30, and as you notice, this is 23. Following this line, which is a little bit darker, this is Helen's. Awesome. So we have Peter's and Helen's, and I labeled my y-axis here. Okay, let's see what's next. Next, use the graph to estimate where the two lines meet. This is the solution. You already knew that. What do you notice about the solution from the graph compared to your solution from part C? All right, so first let's go and estimate where the two lines meet. We'll go here. Here's where the two lines meet. I'm going to make a point there. And now I want to see what my x value is, because remember, when we write the point, it's going to be x comma y. So I need my x value. So I'm going to go here, and I'm going to follow it all the way down to here. So again, I have to see what we're counting by on the x-axis, because it doesn't tell me the exact number here. So let's look. This goes 0 to 50 here. So I'm thinking they're also counting by tens for each box. So 10, 20, 30, 40, 50, and I'm right. So if we go here, this is 150, and you can see it more clearly on yours. So 150, counting by tens, 160, 170, and this is 180. So my x value is 180. Let's look for y. So I'm going to go back to my point, and I'm going to go over to locate that. Again, we're counting by tens as well. So this was 100 on yours, 110, 120, 130. This is 140. So that's my y value, 140. So this is where they meet, 180, 140. So let's write that down. Two lines meet at 180, 140. So 180 are the number of miles, and 140 is our total cost. So that's pretty good. So that's the solution. Now let's answer, what do you notice about the solution from the graph? This is our graph one, compared to your solution from part C. So I'm going to label this graph, and then I'm going to label part C. So let's go back and see what we got at part C. So part C is here, part C, and x is 180 miles. So I'm going to label that. X equals 180 miles. Oh, look at that. 180 miles, 180 miles. It's the same. And I'm actually going to take this one step further. I'm actually going to do part D. Y equaled, and let's look at part D. And that was here, part D, $140. And that was the same. So I actually located both to make sure both the miles and the, sorry, those lights just went off, the miles and the total cost was the same. And we're back. Okay, that probably was a good little break there. All right, we have two parts. We have J and K left. Four. Let's keep going. Okay. Part J, use the graph to determine which company charges a lower fee for a 160-mile trip. Explain your reasoning. Okay, so we're looking for a lower fee for 160 miles. So let's go back. We're going to have to use our graph. So lower fee for 160 miles. Let's go and look for 160 first. So this is 150. So right here, this is 160 miles. So let's follow this up here. And we're looking for the lower one. So that's going to be the first one. So this is the lower line. If we wanted more, then it would be the one above the higher line. But we don't. We don't want to pay more. We want to pay less. So this is the lower line. This line is the bold line, and that's Helen's. This line, bold line, we follow it, that's Helen's. So the lower fee, Helen's haulers charges the lower fee. The line was below Peter's. Okay. So the line was below Peter's. You know what? I'm wondering how much that is. So let's go back. I'm going to go back to Helen's line. This is Helen's line. Let's see how much Helen about she would charge. 110, 120, maybe 121 right here. No, not even 100. Yeah, maybe 121. And if we notice, if we followed Peter's over, it would be even higher here. So probably going to be somewhere around the 120. Okay, use substitution to determine which company charges a lower fee. So we have to do some labeling here. So we're going to write down Peter's. Peter's is y equals 0.40x plus 23. We're going to write down Helen's. Helen's is y equals 0.65x plus 68. 68. And making sure that's right. Sorry for all the flipping. No. Why do I always get those mixed up? Maybe because there's like lower number, lower number. This is our 68. She'd be like, no, Dr. Muir, stop. This is your 23. Okay. Now that we have the right equations, always check first, by the way. What we have to do is lower fee for 160 miles. Remember, 160 miles represents the x. So we have to substitute in. So again, we're making a prediction for each one. Substitute in 168, and let's see what our y value is. Whoops. Plus 23. So here, doing our math in our calculator, I'm just going to multiply 0.40 times 160. And then I'm going to add 68. I'm going to get 132. So that's how much Peter would charge. And then for Helen, I'm going to do 0.65 times 160 plus 23. And this is about 127. Oh, I said around 120 something. So there we go. So now I'm going to circle this. I'm going to say lower total cost. And was the answer the same as the one from the graph part J? Yes. Helen's is lower. So we got the same answer using two different methods. The method from the graph, looking to see which line was lower because we're looking for lower, And then the method substitution, this is your algebra. Helen's is lower. Okay, 2 more. Next, part L. Use a graph to determine which company will move a greater distance for $200. Explain your reasoning. So we need to see which one greater distance for $200. So now we're looking at the Y. So we need to go to $200. Here's 150, 60, 70, 80, 90, 200. Ooh. Have we run out of room? I'm just going to extend these lines and extend my graph. I'm going to use my imagination and extend it up a little bit so that we meet 200 here. And I'm going to extend my lines because we can do that. We can extend our lines. So which one is going to which one are we going to be able to go a greater distance for 200? So Helen's is here. And if we meet Helen's and we go down, it's going to be someplace around here. Okay, well, if we keep going, we're going to hit Peter's. Peter's line is going to be someplace around here. This is going to get us the greater distance. So I'm thinking it's going to be Peter's using our graph. So over here, I'm going to say Peter's will move a greater distance. Our line landed at a further x value. Peter's will move a greater distance. Our line landed at a further x value. So let's see if we can actually prove that using substitution, which is next. Use substitution to determine which will move a greater distance. So here's Peter's. Y equals 0.40x plus 68. Got it this time. Here's Helen's. Y equals 0.65x plus 23. Now here's the thing. This is dollars. That's Y. So we're taking our Y out and we're putting 200 in. So this now becomes a solve for X. Y out, put 200 in. This is different than when you were solving for Y because we have to now use our algebra skills and solve for this X. So I'm going to do Peter's first. I'm going to bring the 68 over. So in my calculator, I'm going to do 200 minus 68. I'm going to get 132.40x divided by 0.40. And so this is going to give me the miles. So 132 divided by 0.40 is going to give us 330 miles. Okay, so this is Peter. Let's see what Helen. Again, subtract the 23. So we're going to do 200 minus 23, 177. Equals 0.65x. We have to divide by 0.65. So x is going to give us the number of miles. So we get 177 divided by 0.65. 272.3 miles. And this is Helen's. And now remember, we want the greater distance. So which one's farther, 330 miles or 272.3 miles? And you got it. Peter will take us farther. And was this answer the same? Yes, we said Peter's line will move a greater distance, greater x value. And here we just proved it. Peter will take us farther. Yes, same conclusion. Go with Peter. So that is a lot to take in. I'm about at 24 minutes and 26 seconds. Keep on ticking down. So if you need to review any part of this, please go back and review it. I do have a practice for you next and then a review. So please go and get that. But first, make sure you review this if you didn't understand a part. I'm Dr. Mears. This is Solving Systems with Word Problems. I hope it helped.